So we have one more application of adiabatic cooling. Adiabatic cooling explains so much. This is another local phenomena that we need to know about. So for this drawing, we're going to start with a mountain. All right, here's a mountain. But there's a few things. This mountain has to be next to the ocean. All right, so here's the ocean. And you have to have the wind coming from the ocean going to the mountain. All right, so what do we know about air that's over the water? Well, we know it's wet. So this is wet, and since it's close to the bottom, it's wet and it's warm air. So it's wet, warm air. Well, what's going to happen when that wet, warm air hits the mountain? Can't go backwards. There's other air there. It can't go into the ground. So it really only has one choice. And you can figure this drawing out entirely yourself. It's got to go up, up, up over the mountain. And here we go. There, we've already set it in motion. We got air moving up. What happens every time air moves up? So this time we're going to write that the air is, this time it's forced up, right? It's going to go through an area of lower pressure, right? So it's going to expand. And if it expands, it's going to cool. And if it cools, the magic thing for the day, the relative humidity is going to increase, right? Because colder air can't hold as much water. And at some point, we're going to hit that magic line and we're going to get condensation, right? So here's our cloud and the rain. And let's write that down. This is at the, this time I'm going to write dew point, because we can call this the condensation level, saturation point, dew point. I'll just call it dew point there. So we got air, and it's going to rain on this side of the mountain. Well, let's just take this, continue on over. So now this air is coming back down over the other side of the mountain. All right. So now we have air moving down. And what do we know about this air? Well, we know that this air is drier because it just lost a bunch of moisture on this side of the mountain, right? And as it falls, the opposite's going to be true, right? It's falling. So instead of expanding, it's going to contract. Instead of cooling, it's going to heat. And then the RH, right, the relative humidity of air that's getting warmer and warmer and warmer is going to drop, because it's like that cup getting bigger and bigger and bigger with the same amount of water. It gets less and less full. And like I said before, if the RH is dropping, ain't never going to get to 100% if the number's getting smaller. So what are we going to have over here? This is going to be a desert. Pretty cool, huh? So we have, this is going to be hot, dry air. And so this air just is, you know, there could be moisture in it, doesn't matter. But if it's coming down, it's never going to reach a saturation point. And if this wind keeps on going this way, this is going to be a desert. And there's some of the driest places in the world are in what we call rain shadows. So that's what this phenomena is called, is a rain shadow. So this side of the mountain is in a rain shadow. It just doesn't rain there. Now, for it to rain, maybe the winds would have to switch, or you know, something very strange has to happen. So here's just another example of adiabatic heating, right? So this is, adiabatic cooling on this side, right? And we have adiabatic heating on this side. We got rain over here, and we got desert over here. I think that stuff's beautiful. You can understand a lot more when you look at a map when you understand this. That's it.